This paper presents HexaMorph, a novel reconfigurable and foldable hexapod robot that can continuously deploy itself from inside out, shift the shape of its own body, and employ a squirming locomotion. The whole robot is fabricated out of the crease-cuts pattern on a single sheet of cardboard. In the folding scheme, we introduce a simple and modular building block called Basic Structural Units, or BSU for short. Here, we show the 2D pattern of a flattened skewed tetrahedral BSU. Unlike other self-reconfigurable robot prototyping, the electronic and battery components for actuation are allowed to be preassembled on the 2D crease pattern. After enclosing all the components inside when the patterns are folded, we complete constructing a skew tetrahedral BSU. It comprises of a pair of mirror image tetrahedra coupled with a middle common hinge. For each BSU, we model the paper creases as the revolute joints, the uncreased facets as the polyhedral surfaces, and closed-form surfaces as the rigid kinematic linkages. Next, the fabrication and folding principles are demonstrated for the whole robot. 3 mm thick corrugated cardboard segments are used as the substrate surfaces. First, we linearly duplicate a single pattern of skew tetrahedral BSU along a strip of sheet, and then we lay down and secure all the control and actuation components on 2D. We fold each individual pattern up in order to obtain a long BSU string. The BSU string is then threaded along in a Eulerian cycle which starts from one arbitrary BSU and visits each of the rest BSUs exactly once. After closing all the disconnected compound joint together, we construct this 6-rayed starfish-like robot, HexaMorph. Each limb in its compact volume is 15 inches long, 13 inches wide, and 4 inches tall. The robot's net weight is 27 ounces, including all the cardboard substrates and an overall 6 pounds with all the functional components. In this paper, we propose 2 reconfiguration patterns for HexaMorph, self-deploying and locomotive squirming. Self-deploying is the motion that HexaMorph is capable of flipping continuously from inside out. Starting from a standing configuration, it deploys its shape through a fully deployed configuration lying on the ground and then towards the final bristled shape. This particular type of reconfiguration allows a robot to transform from a functioning stance with all stretched limbs to a storage or packaging stance with a compact volume size. The second reconfiguration designed for HexaMorph is a locomotive squirming. We decompose the hexapods into 1 forelimb, 4 middle limbs, and 1 hind limb. After deploying its huddled body into fully deployed reconfiguration, the robot first moves the forelimb forward while anchoring the hind limb. The whole skeleton is stretched along the squirming direction. The robot then pulls the hind limb to slide forward while anchoring the forelimb so the skeleton contracts back to the original configuration. Therefore, the overall motion proceeds like a squirming inchworm. One-way friction strips are attached to ensure that the moving and anchoring happen simultaneously towards the same direction.